Hello, good evening everyone. Myself Arnab Ganguly, Assistant Professor of Electrical Engineering Department in Gargi Memorial Institute of Technology College. So this is the class of Electrical and Electronics Measurements. Today our topic is signal generator. In our previous class now we are discussing for the last few days about the different digital meters, and there we have already concluded about the digital frequency meters, digital multimeter, various types of digital voltmeters, and then now today our topic is the signal generators. So what is signal generator? From the name it depicts that generates different types of signals. So if we are discussing about the basics definitions, that is, signal generator provides a controlled output waveform or signal for using, testing or aligning or in measurements on other circuits or equipments. That means it provides a controlled output waveform. Controlled means, that means the controlling of frequency, the controlling of amplitudes, etc. So that controlled output waveform or signal that is generated by this signal generator, which is actually using for the testing purpose or the measurements on the other circuits or equipments purpose, we can generate it. Now normally the signal generators generates the variety of waveforms. That means we can consider about sine wave, square wave, sawtooth wave. So these types of waveforms that is generating in low power. So here firstly, if we are considering about a oscillator circuit, that is a very known to us. So the oscillator circuits, the functioning of it to provide the sinusoidal output voltage at specific frequency. That means if we are considering about to convert a particular DC signal into AC for a specific frequency, then we can use the oscillator circuit to provide the sinusoidal output signal at a specific frequency. That means the oscillator, this is when can be used for the frequency modulations part. That means that is we can use for frequency modulations part. So modulations, if we are considering about this term modulations, that means this is controlled, this is controlled in a wide range as per the desired outcome. So that is the modulation. So we are considering about two types of modulations. One is frequency modulations, another is amplitude modulations. Now if we are considering about function generator, so what is the function generator? So as per the name, that is the generating the several output waveforms, and where the amplitude modulations and also the frequency modulation done, and with the requirements of our circuits, the function generators provides us the several output waveforms like the square wave, sine wave, etc. Now when we are considering about the signal generator, that means at a particular frequency we are considering about the AF and RF signal. That means the audio frequency generator and radio frequency signal. Now these type of signal generators, the AF signals and RF signal generators, is actually designed to cover the wide frequency. So wide frequency means here the frequency range that can be few hertz to the few gigahertz. So now as per the outcome, the signal generators can be classified into different generators part. That means it can be radio frequency generator, it can be audio frequency generator, it can be pulse generator, like it. But the few characteristics of the signal generators is same to the all. That is number one, that is frequency should be known and stable. That means the output frequency that is specific to us, and on that specific frequency the modulations has been done, and the output frequency, output waveform frequency, we get in our desired level, and that obviously should be a stable output. Number 2, the amplitude. So we already considered about the frequency modulations and the amplitude modulations. That means the amplitude means the value, the magnitude of a particular waveform. So that is also a controllable, that should be controllable, and the output should be varied from a wide range, in between a wide range. So the amplitude of the output signal, that is also should be controllable, because we are here actually going to generate a signal as per my desired outcome. So obviously the signal amplitude, frequency, the basic parameters has to be controllable. Number 3, the signal should be free from distortions. That means obviously we are considering about the stable signals, without noise signal, without distortion signal. That means a stable particular signal. Now when we are considering about the applications part of this, so the first applications, that is the appropriate signal provider for different type of circuits. We already in the definitions considered about the controlled output waveform using for testing or measurement purpose. So that is the appropriate signal provider for calibration, for testing and troubleshooting amplifier circuit in communications, radio and televisions. So in the communication circuits and the radio TV circuits amplifier, there these types of signal generator we are using. Number 2, that is employed as a power source for the gain measurements and the bandwidth parts, and also it can measure the characteristics of the antennas and transmissions lines. So when we are considering about the applications, this is obvious that to do these applications we have to provide a particular signal to do the applications, to do the testings. So now to give that particular signal at a particular specific output level, we have to control its frequency and amplitude. So we considered it as a frequency modulated and amplitude modulated output waveform. So that is obviously should be controllable. Now if we have done the classifications of signal generator, actually with respect to the different frequency level, we can make a chart for the various frequency level the signal generators applicable. Now this is the classifications, that is number 1, audio generator, that is the audio frequency sine and square wave generator. Number 2, function generator, that is very common to us, that is function generator, we are using that in the labs to get the different waveform, like already we have discussed about the square wave, sine wave or sawtooth wave or whatever it may be. Now when we are considering about the sawtooth wave, see the function generator actually going to produce about the sine wave, square wave, etc. For the sawtooth wave, that means that is a train of pulse, we can use the pulse generator. Already when we have discussed about the digital voltmeters and the digital frequency meters in our last class, then we can see that there is an oscillator of fixed frequency that is providing a train of pulse that is passed through the gate and helps to get the desired output in the meters. So this is the pulse generator that is going to generate the train of pulse. Another is radio frequency generator, frequency synthesizer. The frequency synthesizer actually what does it means? That is from a single reference frequency. Suppose we get a single reference frequency and from that we want to generate a range of frequency in a wide variety, so we can use the frequency synthesizer. That is also actually a types of radio frequency generator, and other types of different signal generators we can we can make the classifications about that. Now when we are considering about a conventional standard signal generator, so for the conventional standard signal generator, that means this is the convention how a signal generator should be how the design of the signal generator should be, that is the convention process, convention block diagram. Now here you can see the total block diagram of this conventional standard signal generator, where here that is a RF oscillator part, that is a output attenuator part, and this is the modulation circuit. Now if we are considering about a sine wave generator or this type of signal generator, here the total block we can actually divide it into two parts. One is oscillator part, another is attenuator part. So when we are considering about the oscillator part, previously we also discussed that the oscillator actually provides the sinusoidal output signal in a particular specific frequency. That means for the frequency modulations part and the distortionless output waveform, the oscillator circuits actually going to works on that aspects, and for the attenuator part, that is actually working on the output amplitude. So now if we are considering about the conventional standard signal generator, so see, this is the block diagram. See the block diagram of this signal generator, that is the RF oscillator. Here we can use RF oscillator, means that is a radio frequency oscillator, that is a amplifier circuit, output attenuator, output meter, that is indicates as the output of the generated signal waveform. That means when we are considering about a signal output, that means the signal output is in this nature, that is how its waveforms depicts, and its amplitude, its frequency, in this manner the outputs actually we can get. Now that is the RF oscillator, means actually this is going to provide a carrier signal. So carrier signal means that is going to carry out the required signals. So these carrier signals is providing by the radio frequency oscillator. Now this RF oscillator actually here works to provide that, and for the amplitude modulations, actually these RF oscillators actually working for the frequency modulations factor, and when we are considering about the amplitude modulations, then there can be used an internal or external sine wave oscillator. That means here we can use a sine wave oscillator, that is working on the aspects of amplitude modulations. Amplitude modulation, and this RF oscillator, this is actually working in the aspects of frequency modulations, and that is providing a carrier signal. Now for the modulations part, we can also use like square wave, triangular wave, etc. instead of sine wave. Now when we are considering about this diagram, the carrier frequency is produced by this RF oscillator, that is generally sine wave, and the RF oscillator inside of these RF oscillators, if we considering about the circuit, then there is a tank circuit. So that tank circuits, that means the LC circuits in parallel configurations, that tank circuits is going to generate this particular carrier frequency signal, and this frequency of these oscillations, so that means that actually we already discussed that this oscillator is going to do the frequency modulations. That means the frequency of the oscillations that is shown on the frequency control. Now the amplitude modulations, already we discussed that it can be done by the internal or external fixed frequency oscillator. It may be sine wave oscillator, it may be square wave oscillator, it may be triangular wave oscillator, etc. Now this modulation circuit, here you can see that is a modulation oscillator. So that means it is going to do the modulations on the signal in this amplifier circuit. That means the modulation is done to the output of this amplifier circuit, which is actually delivers the output, that means the modulated carrier signals to this attenuator. That means in the output of the amplifier already we get the modulated carrier frequency signal, that is modulated in terms of frequency and also in terms of amplitude, and that modulation is done with respect to us in the desired outcome. Now this output attenuator, we already say that this output attenuator is actually used, this is also used for the amplitude parts, and in the accuracy of the amplitude part this output attenuator works. Actually this output we get the actual desired amplitudes outputs that we have the requirement. So this output attenuator gets the input from this circuits, that is the modulated carrier frequency signal, and the output of this attenuator, that is the output meter going to measure and indicates the output, that is the output in terms of frequency and in terms of amplitude. So by that diagram this is clear that we get a particular signal that is modulated in terms of frequency and amplitude with respect to our desired outputs, that is modulated, that is controllable in wide frequency variations. Now here we can also use these buffer amplifier circuits, that is employed actually to isolate the oscillator circuit from the high frequency output. So this is the function of this buffer amplifier circuit. Now what is the advantage? So when we are considering about the signal generator part, the advantage is the stable output obtained as per requirement. Already I am discussing that is in terms of frequency, that is in terms of amplitude. So the stable output obtained as per the requirement. Now there is a disadvantage, that is the frequency stability is limited for the LC tank circuit. Actually in the RF oscillator circuit, the circuit design is actually done with help of this LC tank circuit, and the LC tank circuit's disadvantage is that is the frequency stability is very much limited, that means it gives the functioned in the very small range of frequency. So the frequency stability is limited for the LC tank circuit. And another disadvantage is that is take time to stabilize at new frequency. That means if the frequency level is going to change, that means these circuits takes time to stabilize for the new frequency outcome. So these are the advantage and disadvantage of this conventional standard signal generator, and as per that disadvantages, then there will be obviously changes, and for that change we also can get the modern signal generator circuits, which is actually designed with respect to this disadvantage. Actually taking this disadvantage, to overcome these disadvantages, the modern signal generator is actually designed. So that's for today. Today we have discussed about the conventional standard signal generators block diagrams and the basics of the signal generator. That is for a small recap, that is the definitions of signal generators, applications of signal generators, what should be the characteristics of signal generators, and obviously also the classifications part of the signal generators, applications part of the signal generators, and then we discuss about the conventional standard signal generators, how it works and how its gives us the desired output in terms of frequency modulations and amplitude modulations. So due to the for this disadvantage, actually to overcome this disadvantage, then the modern signal generator is going to design. So in our next class we will discuss with that types of signal generators and the others digital instruments. So thanks for all today. Thank you.